Hello everyone, in this video let's discuss about the 1:2 demultiplexer. You can call them as DEMUX also. The full video links of the concept on digital logic design is given in description. You can learn with the easy trick and easy understanding. Now let's write the block diagram, truth table, characteristic equation of the output and the logic circuit diagram for 1:2 demultiplexer. As the name suggests, 1:2. That is, there will be only one input and there will be two output in this demultiplexer. Now let's represent their block diagram. In block diagram, what we will be doing is, we will be just representing what are the inputs and what are the outputs in the circuit. So we are having only one input and we are having two outputs. Let me call the input as I1, or you can call it as input I, and let me call the outputs as Y0 and Y1. This is 1:2 DEMUX. Now the input will be coming, and through which output the input must go will be decided or selected by the selective lines. So selective lines. So how many selective lines will be there? Will be selected using a technique. That is, here 1:2 demultiplexer. Round the output value. What is the output value? 2. How you can represent 2 in the 2 power? 2 power 1 will be 2. So therefore only one selective lines will be used in the 1:2 demultiplexer. Let us call it as S0. If it was 1:4 demultiplexer means, 1:4 demultiplexer means how you can represent 4? 2 power 2 will be 4. So 2 number of selective lines will be used in the 1:4 demultiplexer. Like that only for 8, 2 power 3 will be equal to 8. 3 number of selective lines will be used in the 1:8 demultiplexer. Now we are designing 1:2 demultiplexer, so only one selective lines will be used. And with this, in the demultiplexer, there is a concept called enable. Without this enable, you can't start the process or the circuit will be in the off state. The enable value must be equal to 1, then only the circuit will be on and you can do the operations. So this enable and selective lines S0 will be acting as my inputs and my outputs will be Y0 and Y1, because the input that you give will be selected and the input that you give will be taken, and among these two output lines it will be selected through the enable and the S0 and given as the output, like that. Since I am having two inputs, my possible combinations are 0 0, 0 1, 1 0 and 1 1. Now I already said that when enable value will be equal to 1, then only the circuit will be in the on state and you can do the operation. Whenever E value, that is enable value, will be equal to 0, no operation will be proceeded. So whenever enable value will be equal to 0, no operation will be done. When enable value will be equal to 1, the operations will be done, and here if you see S0 value is equal to 0 and here it is 1. Let us assume that when S0 value will be equal to 0, the input I will be coming through the output Y0. So I will write I here and this will be 0. Vice versa, for condition with 1, when S0 value will be equal to 1, let us consider the input I will come through the output Y1. Now let's write the equation for the outputs. Here I am having two outputs, that is Y0 and Y1. For Y0, if you see, here I is there, round it up. What are the values? E value is 1, S0 value is 0 and I1. E, S0 bar and I1. No I. Next, if you see for Y1, E, S0, I. E, S0 and I. Now I want to design the logic circuit diagram. So enable is common. I will take like this itself. Next S0. S0 is there, S0 bar is there. So S0 I will take and I will add the NOT gate so that you can represent S0 bar. And another one is I. So I will take here itself. Now the first one is y0. What is y0? E, S0 bar and I. You will be adding the AND gate in between them because dot multiplication. Next, this is of y0. Now let's write for y1. Enable S0 and I using the AND gate. This is for output y1. So this completes the 1:2 demultiplexer. If you have any doubt regarding this topic, please do comment below. If you liked the video, please subscribe and support us because your one support motivates us to make more engineering related videos. Thank you.